Good morning, everyone. My name is Camila Garcia, and I'll be talking to you about differential detection and analysis of DNA from various substrates commonly found on crime scenes. So one of the most challenging things about forensic biochemistry is the fact that um, getting DNA from fingerprints involves low copy number DNA. This DNA is DNA that is in a minimal amount, and PCR and capillary electrophoresis techniques have been tailored to this kind of DNA. So the amount of DNA that you can get from fingerprints is about 200 picograms, which is very low. This means that there is different analysis and collection techniques that we need to use. So the PCR and capillary electrophoresis can throw alleles that are optimal for analysis. Short tandem repeats are what the capillary electrophoresis is looking for, and these are human identification probes that we can use so that we can identify the suspect in our crime. As we can see on the far left, on the bottom, we can see that there is an SCE, a capillary electrophoresis analysis. It's a mixture. As we can see, there is many alleles. We usually typically only see one or two alleles for each person. So this indicates there is a mixture. So this study aims to find a way to get DNA from fingerprints that can be used in a court of law for law enforcement to have another way to identify a suspect. Because we can collect fingerprints from a crime scene, put them in the system, and then we don't find the person. So that will be an issue. If we can get DNA from this fingerprint, maybe we can find them in the DNA database instead of on the fingerprinting database, and that gives us like another way to find a person. So the first steps of this research was to plant fingerprints on different objects used as murder weapons. In this study, we used a hammer, a water bottle, a knife, a phone cord, a screwdriver, and a mirror, as we can see pictured on the middle of the screen. And these objects were fingerprinting, and then we revealed the fingerprint with black powder. After we swabbed with a cotton swab, stored them in sterile water, and then we did a helix extraction of the DNA. After that, we performed PCR, amplification, and capillary electrophoresis analysis. For some of these samples, we did a time trial of so we can determine the degradation of the DNA over a period of 2 months. And then for another part of the samples, we examined different techniques of amplification and analysis in the capillary electrophoresis. We used different methods in both the PCR, as in changing the PCR cycles, and also we changed some techniques in the capillary process. So one of the techniques that was used was a changing the 5 second to 9 second injection point, and this gave us one of the best results for our percent of alleles that we got back in the analysis. However, the one that gave us the least was evaporating our sample and then doing a 1 to 1000 dilution of this concentrated sample. That gave us the lowest yield of alleles. It just didn't work as we thought it could. So the future direction that this study can take is that we plan to do a pilot manual so that we can um, show law enforcement this tailored new techniques that can be used for low copy number DNA, and that they know how to collect this fingerprints in a way that we can store the DNA and the DNA doesn't get degraded. So we're also trying to do post PCR amplification processes and purification techniques. Um, Thank you.